Welcome all to the analog lecture series. So far whatever the content that I was delivered, if you really understand, don't forget to click that like button and kindly share our videos with all your friends. Okay, let us looking into the solution for this question. As I told you all to use your mastermind to bring the relation between output voltage and input voltage. Remember one more thing, whatever the procedure or things that I am applying here, this will be common for all upcoming questions also, because this will be standard. Either you have to apply KCL, KVL, redraw the transistor equivalent circuit, do it again and again, you will be getting the answer. That's all. Okay, let us see. I told you the current through this terminal is collector current, right? So from where this current is coming? Now if you observe the question carefully, see that current has to come from here only, because this is open terminal. Just we are observing the voltage here. So if the current is going upward for the 1.2 kilo ohm resistor, current entering point plus leaving point is minus. Yes or no? How will you write down the voltage drop? Then the current entering point plus leaving point is minus, and the voltage drop for this resistor can be written as 1.2 kilo ohm resistor into current flow through the resistor is IC. And the polarity is C. This is plus, this is minus, because for a resistor current entering point will be plus, leaving point is minus. I am repeating, it is standard for all other upcoming circuits also. Once you understand this one clearly, then everything will become easy. So try to understand. Okay sir. And then if you observe the relation, actually voltage, here we are having plus, here we are having minus for the voltage polarity. So what is the conclusion? The voltage that we are trying to measure across this resistor is opposite to the actual voltage drop, because the actual voltage drop is collector current IC into 1.2 kilo ohm. 1.2 kilo ohm means 10 power 3. This is what I am getting. Why I am putting minus? According to the current I am getting one relation, according to the voltage I am getting one more relation. Now treat this one as your equation number 1. Let us go ahead with the input loop. See that this is the input supply. Always if you are taking the current direction for the source, for a source current entering point will be minus, leaving point will be plus. For a load, current entering point will be plus, leaving point is minus. Resistor, inductor, capacitor, all are always acting as a load. That's why for them current entering point will be plus, leaving point is minus when they are acting as a load. Sometimes inductor and capacitor will be acting as a source also. When they are acting as a source, during that condition, automatically source means what? Current entering point minus, leaving point is plus. This concept will be applied. Okay sir, come to the question. Source is delivering the current, so current entering point minus, leaving point is plus. This current will go here. Here current entering point plus, leaving point is minus. After that this current will go here. See there, now there are two currents are entering. One is beta times of IB is coming here. Of course, we are simply calling it as collector current IC only, and here we can directly take IB. Okay, because IC is equal to beta times of IB, but in our question we are not going to consider the value of beta. Why sir? Sorry, I am not going to consider the value of IB. Why? Because in the question they told that the value of beta is very large. When the value of beta is very large, we cannot consider the value of base current. It means indirectly they are saying that the value of collector current and emitter current both are equal, and the value of base current is approximately equal to 0. I am repeating, approximately equal to 0 means you can't take 0. But you can ignore the effect of base current. Wherever you are having base current, there you no need to consider that effect, you can put 0. So during these cases, what you have to do is, in collector terminal, consider only collector current, don't consider beta times of IB. That's my suggestion, because what you will be thinking is IC equal to beta times of IB sir. If I am putting IB equal to 0, IC also will become 0. Then all parameter will go 0. You no need to do any analysis. Yes or no? Everything will become 0 if you are doing in that way. So what you have to do, whenever you are ignoring the effect of IB, directly take collector current IC, and wherever you are having emitter current also can be replaced by collector current, because IC and IE will become equal. That's all. And you can replace the value of base current is approximately equal to 0 sir. Don't put 0 here, because here we are considering collector current only. This can be considered as IC. So IC value will exist. Why? Because the value of base current will be in microampere. That's why we are putting approximately equal to 0. So when we are multiplying microampere with beta is very large. They told beta is very large. So very large value will get multiplied with the microampere. So you will get some reasonable value for the collector current. Collector current will not be 0. Only base current alone will be approximately 0. When you are multiplying base current with beta, large value of beta, collector current will exist. Okay, fine sir. So let us apply KVL. Now current entering point plus, leaving point is minus. After that, see that What is the current that is coming here? Collector current only. And 1 kilo ohm Re, both are connected in parallel. So we can directly 1K into Re upon 1K plus Re. K means 10 power 3. That is the equivalent resistor. For this, for the whole resistor, current entering point plus leaving point is minus. What is the amount of current entering? Emitter current only, or we can say collector current. So emitter current into this voltage, emitter current into this resistor will give you the voltage drop, because this is the total resistance. Total resistance into current entering into the resistor is IE. Now if you apply KVL, can I write like this? Minus Vn plus beta times of Re into base current IB. They told, see there, beta times of RB into base current IB. But already I told, whenever you are considering beta base current alone separately, this is 0. You can directly put 0. It means the voltage drop across this resistor will become 0. You don't need to consider it. You can ignore the effect. Directly I can put this whole value will become 0. Don't get confused with this and this. Base current alone will be 0 because of the total portion we are ignoring here. Okay, so I am ignoring that effect. So whenever you are considering base current alone, when the value of beta is very large, we can ignore that. So the another only voltage drop is emitter current IE, or we can say collector current IC into 1K into Re upon 1K plus Re. That is the equivalent resistance of parallel circuit. From this, what we can say, the value of input voltage Vn equal to collector current IC into 1K into Re upon 1K plus Re. So we found the value of input voltage. Treat this one as your equation number 2. Already we got the relation for output voltage. See there. Now it's time to take the ratio between input and output voltage. So let me do that. So let us take, finally after crossing 4 lectures, we got the answer for this question. The ratio between output voltage and input voltage can be further written as, simply if I will take the ratio between them, what I will be getting? See there, IC is common for both. It will get directly cancelled. And the output voltage is minus 1.2 into 10 power 3 upon 1K into, what is the value of Re? Do you remember? By doing DC analysis, we have been already explored the value of Re. Where is it? I think I kept it somewhere here. 1 minute. Yes, the value of Re is 10 ohm. Now you can take that and substitute the value of Re here. So that is 10 divided by 1K plus 10. 1K plus 10 is approximately 1K, because 1000 plus 10 will become 1010, or approximately equal to 1000 only. So from this, what I can say, this KK will get cancelled. After that, so what I can say is minus 1.2 upon, we are having 10 still, under denominator 1000 plus 10 will become approximately 1000 only. I am simply simplifying this. 10 will get cancelled. Anyway, denominator of denominator will come to the numerator. Finally, this value approximately equal to minus 120. So we found the value of voltage gain. The voltage gain for this circuit is V0 by Vn equal to voltage gain, means it will be represented. A, we are always using A to represent the gain. AV means voltage gain. So voltage gain will be approximately equal to minus 120. So happily we got the answer for this question. See, it doesn't matter whether we are getting the answer or not, but you have to understand this procedure, whatever I did and whatever the things that I have given here, that you have to observe it carefully and try to get the relation between all the parameters. See, in place of Re, I can substitute pi. In place of pi, I can substitute H. It means, what is the conclusion? I can bring the relation between the parameter. Like here I am having R pi, yes, and here I am having beta times of Re. Here I am having H times of IE. You can equate all these parameter. So by equating all the parameter, what we can do is we can simply bring the relation between the parameters. Here I am giving the relations. So what we can do is I can say R pi equal to beta times of Re equal to HIE. I will be telling you later, I will be define this hybrid model. E denotes the emitter configuration, I denotes the input. Okay, so later we will be understanding everything. Re, you know, beta means gain, you know. R pi, once again in the pi model we are exploring the value of resistor, that is called R pi. Okay, so from here we can also proceed further. So I have written that this is R pi equal to beta into beta Re equal to HIE. And one more thing, what is the another relation? See there, Gm into V pi. Right, so Gm into V pi, and I can also equate it with the GFE into IB. and you can also equate it with beta times of IB. So if I will equate it these parameters, what I will be getting is, that will be very easy. So here if you compare this beta into IB with the HFE into IB, I can directly write that the value of HFE equal to beta. Yes or no? See there, here HFE into IB, here I am having beta into IB. So these both are equal only. In the same way, if I will bring the relation between this GM, R pi and beta, you will be getting one more relation. Let me write directly here, R pi equal to beta by GM, that is the another relation. Actually this is the most important relation. Directly there are some one more question in the examination. Try to remember whatever the things that I am delivering. I told you through the questions slowly I will be covering everything. Okay, though we are solving the question, it is my responsibility to cover whatever the content that are required in order to crack all the questions. So here almost I have given 40% of the concepts to crack all other questions, and my sincere suggestion is one more time watch all these 4 lectures such that you will get the idea how to do DC analysis, how to do AC analysis, why we are doing DC analysis while doing AC analysis. You have to get the complete conclusion. So this is all for this lecture. In the next class I will be bringing one more most beautiful question, and we will be understanding how to solve the questions directly. So this is all for this lecture. Remaining things we will see in the next class. Thank you all.